which goes a little something like this. Hello and welcome to the Hackaday podcast. My name's Elliot Williams. I'm editor-in-chief of Hackaday.
And I am Tom Nardi, managing editor.
This is episode 160. This week we'll be talking about pedal power, OpenSCAD in the browser, Tasmanian tigers, and the coolest knob. Short news week this week, but an important one. The news coming out of southern China is that Shenzhen is closing down for a week. They have a new strain of COVID making the rounds, and so basically everybody is quarantining. We covered this in a story, Hackers Beware, Shenzhen is closing, and it looks like it is hitting all of your favorite stores, industries, makers. How long is it going to be? Is it just like 2 weeks or 1 week? What did they say?
A week-long lockdown is what the link.
Okay, so it's only a week. That's actually comparable to Spring Festival / Chinese New Year, right?
Yeah, right.
Like, so that's not so bad.
Well, I mean, it's definitely worth keeping in mind. I've actually already gotten hit with this. It was funny. I had ordered something from China on eBay like a couple hours before this story hit.
Oh, no way.
And I got the notification. I said, oh, yeah, it's shipped, no problem. And then not long after this, I read about it on Hackaday. I saw this story on Hackaday. And then I got a notification from eBay. And they're like, sorry, but apparently we have to close the country down. You know, they said, like, we've been informed by the Post that we can't send things out of the country or something right now. I was like, oh, that's kind of weird, but all right.
Yeah, actually, it looks like from some of the reading I'm doing right now that it's not going to be such a big deal. It's like, it's going to be delays, but it's not going to be like the kind of close down / lockdown / complete shutdown of the entire country that happens with Chinese New Year's.
But I mean, it's still interesting when so many of us are kind of peeking our heads out after, 2+ years of COVID lockdowns that, it's a reminder that it's not going away. It's still here. It's still something we have to keep an eye on.
Yeah, the Chinese are fierce about their lockdowns too. I mean, part of this is their experience with the previous avian flu pandemics and then SARS. So they've kind of got this drilled down a little bit better than the rest of the Western world. Plus, they also kind of have a differently structured government that's more willing to shut things down quite rapidly. And honestly, China has a different kind of attitude on the kind of communal benefit versus individual rights trade-off. And regardless of which government's in power, they seem to make choices differently from the way we often do in the West. So
yeah, I did a double take when I got to the part of the Post, and I said, like, there's 121 cases. So I was like, that's it? Like, that's nothing, but...
Oh, yeah, we've got 3 times that many in a city of 1 million, not 12 million.
In the U.S., we've kind of just hit the point where it's like, this is a way of life, and we just kind of move on. It's not going anywhere, as long as it's manageable. But clearly, they have a different game plan over there.
This is a journey into sound.
What's that sound?
What's that sound?
This week's What's That Sound is courtesy of my wife. See if you can figure this one out.
Oh, you gotta be kidding me. They're gonna get it.
That wasn't even one. Could name that in tune in 2 notes.
Oh, yeah. This is too easy. I don't know how you make it harder, though.
Fantastic. Well, I'm glad it was too easy. I hope some people get a t-shirt.
I hope you're ready for a lot of email responses.
Well, if you know what this... I said again. If you know what this mysterious music is from, please head over to Hackaday /podcast, fill out the form. We'll pick a random winner from the correct answers and send you a t-shirt. Stay tuned till next week.
You know what? I'm fascinated. I would assume that would be very easy with our audience, but maybe not. Maybe I'm projecting my own.
We'll see.
I would, if they don't,
If you don't recognize this, you've got a week of lost time.
Yeah, I'm almost envious of you because you get to experience it for the first time.
That is the truth. Starting off the hacks this week, I would like to present you Low Tech Magazine's Pedal Powered Power. The idea here is really simple on its face. It's to make a pedal-powered generator to contribute electricity to your general household use. So charging up batteries. This is a really neat project because it takes something that you think would be really easy, just slap a motor on a bike and call it a generator, and it takes that premise actually fairly seriously. And it turns out there's a bunch of interesting things to know here, like getting power out of a human being attached to a bike turns out to be a lot like solar in that you can't just say, I want to get this voltage or this current out of it. And in fact, the voltage that the generator makes is kind of proportional to the speed at which the wheel's going around. And the current that the generator can put out is basically proportional to how hard you're pushing it. And so the power that you can put out then is the product of these two, and finding this best speed versus effort point is kind of like it is for solar power. There's kind of a maximum power point idea here. And the interesting parts of this build to me are them considering how to make the power and current that you as a cyclist can generate fit the demands of the devices you would like to charge with it. So like your cell phone, maybe light a light, maybe boil some water, they even try at one point in time. It's a really interesting problem, actually. And there's even one more layer on top of this that makes it yet harder than either the solar or the wind power problem. And that is that people don't want to sit there on the bike for 12 hours a day. And so while you could put out maybe 100 watts for kind of 10 minutes, that doesn't necessarily turn into a suitable stream of electricity to power a cell phone, for instance, which wants to charge at like 5 watts, but for many hours. And so you'd have to sit there to do this directly out of the bicycle. You'd have to sit there pedaling kind of very slowly against very little resistance, but for an incredibly long time. And so kind of matching up these power supply and demand things is the responsibility of a bunch of kind of buck and boost power converters set up in a central brain that also switches between different loads and stuff. It's a really neat project.
Getting power from pedals has been around forever. But looking at the machine reminds me of during the war they would use little printing presses powered by bikes to print out subversive documents and stuff. Like the French resistance would print their little pamphlets on bikes. It looks very similar to this,
Oh, cool.
But that was all mechanical, So I guess the harder you want freedom, you pedal harder. But I would look more deeply into it, but I think the sun is down wherever the website is. So
worth noting here, Low Tech Magazine has another project that we've actually covered before on Hackaday, which is a completely solar powered web server. And when I went to look this up this morning, actually, it was down today. And
it continues to be down.
And I was like, oh, it must be nighttime. And then I looked it up in there in the Netherlands or something, which has the same sun as we do here in Germany. But you know what we got this week was a sandstorm. Europe is weird.
Wow.
It's a lot closer to Africa than you think. And when the wind blows across the Sahara, we get literal Sahara dust, and it covers everything in this like kind of terracotta beige, super fine, gritty dust. And I was just saying this morning, that must be hell on solar generators.
And there you go. It is a really cool build. I like. I don't think you mentioned how it's a friction link, right?
Yeah,
like
go ahead.
They didn't have to cut anything, weld anything. It's actually just a little wheel that's pushing up on the front of the exercise bike, which is reversible if you ever decide that you want to exercise without the benefit of producing electricity. It's simple. He describes it as very beautiful to behold, which maybe he's a little strong, but I don't know if those would be my first words, but it is elegant. I'll give him that.
I'm pretty sure this is half art project just to see like how far you can push it, and then half just engineering fun project just to see how far you can push it, because like there is no reason to try to drive a line voltage dot matrix printer off of a stationary bike, except to say that you can. And that is awesome. They have an inverter on it. They have big lead acid batteries actually for serious power storage. And the idea there is that when you bike, if you're putting out 100 watts and your cell phone can suck up 5, you need to dump this extra energy somewhere. And so where do you throw it? And one answer is into a lead acid battery, but their battery doesn't even take as many watts as a person can give off. So they need to dump the heat elsewhere as well. It does suggest that there's kind of a human regulator possibility in the thing. And what is really funny is they play around with selecting the spindle size that is connected to the motor that then connects it to the wheel. So it's kind of a little bit like a gear there. But this bike doesn't actually have a gear at all.
Right.
And so if this thing had like 12 speeds or something, you could adjust the gear shifter to get like the right voltage and current out of it, I guess, in principle.
Part of the issue with using an exercise bike, right? It was never meant to be a comfortable ride. It was always supposed to be you push against this thing to get
to make you sweat.
Right. So like it, of course there's no gears because they don't want to make it easy for. Imagine an exercise bike where like I'll just be coasting around, and would it make more sense to get a proper bike and just take the front wheel off of it or something and make use of the technology to spin it easier? Because you think it'd be easier to find one of those on the side of the road anyway, too, right? Like how many of these old stationary bikes can you grab? But I mean, a bike is easy to source if you want to experiment with human power.
So there's a bunch of other crazy powering experiments that Chris DeDecker and the others at Low Tech Magazine have dreamed up. You should actually go look at all of them, including the solar-powered web server, which this bike can feed into for extra power. And then if you're interested in squeezing out the last few milliamps out of a coin cell for data logging purposes, we have a neat project that also came out this week from the Cave Pearl project. Basically, they're just snipping all of the things off of one of those little blue pill boards they can to make it run as long as they can. But the results are pretty cool. So I'll throw that link in the show notes too.
All right, well, this is one that I'm personally very interested in. I think Elliot probably feels the same. Jenny List wrote this one up called The Noble Effort to Put OpenSCAD in the Browser. For all its faults, we are big fans of OpenSCAD around these parts.
True.
And I think anything that makes it more accessible and easier to use is a win. This effort, and it is an effort, this is not, it's not just one person toiling. There's actually quite a few people, a couple different parties involved in this. And they say, great minds think alike. To bring OpenSCAD to the browser, so you don't have to install anything locally. You could just go to a website, enter your code, or take somebody else's and get a 3D model that you can download. This story in particular started about a year ago when AutoDrop 3D put out a bounty. They were looking for somebody to kind of port the core OpenSCAD engine, right, for lack of a better word, to WebAssembly. A developer came along, he took up the challenge, and developed what is now called OpenSCAD WASM, which could be thought of as kind of just the command line version. There's no interface or anything. So then what other folks have now done is come up with web UIs for it that look more or less like the local version, and they tack on, an STL viewer and all those kind of things, and they've come up with something that you can just go to a web page on a Chromebook or whatever and go from start to finish, write your code and get a usable file. And I know personally, like one of the things I like most about OpenSCAD is it runs on pretty much anything. If it can run a Linux distro, you can do 3D modeling. You can't say that for a lot of other CAD packages. Even if it was headless, I mean, you could, if you're crazy enough, you could just do it all over, SSH. You don't have to see the preview of. I mean, it would help, right, to see the preview of what you're generating, but you could absolutely, without ever seeing it, go from just entering in the code to exporting an STL just on the command line.
Absolutely.
But that's kind of the extreme, right? Like we shouldn't have to do that. So the idea that any device with a browser, a modern browser, could do that is really cool. Every time we kind of bring up OpenSCAD, the comments go wild, and this post was no exception. It's not for everyone. Like, I get that. We all get that. But I think there is a lot of power in it, and even if you're not the person writing the OpenSCAD code, you can at least benefit from the parametric aspects of it, especially if it was written with that in mind. That customization, especially if you could do it right, you could have little sliders and stuff. So you could have a person who has no idea about any form of CAD, code or otherwise, that they can customize a design, hit a little button, and get an STL that's like bespoke for their needs. I think that's really powerful. And putting that into the web is just like a force multiplier. And I really would love to see more open hardware kind of projects taking this on without even having to download anything locally. You could just tweak the designs, hit a button, and you have your own little build of it without having to get your hands dirty necessarily.
Thingiverse's customizer is basically kind of a web front end to change up your SCAD code to make it customizable by the end user who doesn't necessarily know anything about OpenSCAD. And so there's already a lot of people doing just what you suggested. There's people who aren't necessarily OpenSCAD programmers out there who are using it.
Right. And we should note that the Thingiverse customizer has been perpetually broken for a long time. I mean, Thingiverse in general has been limp. We've written about that in the past. They've been limping along for a while, but customizer specifically, because I have a couple of designs that use customizer and it almost never works. And it's such a cool feature that unfortunately
it's a really good idea.
Other groups are taking this on in an open source, transparent way.
If you aren't an OpenSCAD user out there in the world, what I think it's most like is a programming language. But then what's being replicated here in WebAssembly is kind of the compiler for it. So like you type in OpenSCAD code, it's like typing C, and then you hit compile, and then out comes a shape, an STL file that kind of embodies this 3D shape that then you can send off to get printed. So what's going on here is that they have written basically the compiler, that takes the code and turns it into the object in WebAssembly. And so this is like having any other compiler running in your browser in that sense. It's really kind of a neat trick. All right, my next hack from Scotty Bez 1 is a haptic smart knob that does several jobs. This is definitely the most finished product looking hack of this week. Oh, yeah. It is a sweet little knob, and inside the center it's got one of those 240 by 240 round LCD screens. You can actually press on it in the center to make it a button, but the really coolest part is that the knob slash kind of jog wheel like thing that goes around the outside not only has a magnetic sensor so that you can tell where it is to turn it into kind of an endless rotary encoder, but it's also got a tiny brushless gimbal motor attached to it, and it uses that to give you force feedback. One of the possible ways to code it up is that it has like detents, but another would be to use the motor to fight you for a while and then let go so that you can have like a snap switch, or have it auto center, or have it go to one side and then the other side. Just all of these kind of possibilities that you can do with essentially a servo motor. Because if you think about this thing, what it really is, of course, is a motor and a position encoder and a bunch of software that makes them work together. It's exactly a servo motor, except it's one that's meant to be turned. And I just love that idea. And you can see that Scott is playing around with kind of all of the different possible interaction modes here. And I just love seeing him explore this. I thought to myself, oh my God, one of these gimbal motors, this has got to be the most expensive thing. There's no way this will ever work. It turns out you can get these motors for $4 each, basically, from China, at least when Shenzhen is open.
Yeah, right.
And the rest of the bill of materials isn't super bad either. There's like a magnetic encoder and... Oh, actually, one of the coolest parts is instead of a button in the center when you press it, he uses 2 strain gauges, and I think he's like super glued them to the PCB and then routed out little cutouts in the PCB so that you can actually bend the PCB and use the strain gauges to tell when it's being clicked on. don't know that that's any better or different than a tack switch, but I guess it lets you do kind of analog pressure, and it's just hella cool.
That's like the description of the whole project, right? It's just hella
Hella
cool. Like, I don't know if it's better, but it's hella cool. But no, it is a phenomenal. It reminds me of like the Nest thermostat, but I guess that one doesn't have obviously like the motor and stuff in it. No, this is really cool. I mean, if auto manufacturers are hellbent on changing the interface of their cars, I would like them to do something like this rather than a big touchscreen. Like, let me have physical controls where you can program in like it's on the D10s, the force feedback, and yeah, so cool. I like like you're saying, like the idea like a snapback kind of thing where you'd push against it, and it'd go back, but only when you need it to. Like it could be so many different interfaces. Like I said, it's not impossibly. It's expensive. I mean, there's no way around it. It's pretty expensive for a knob. In the grand scheme of knobs, this is a fairly high end one. But economies of scale. Something like this became more common, and it drives some of those prices down. Or I suppose you don't need all the features either. You could do some kind of a light version maybe.
You don't need that LCD screen in the middle, maybe.
Oh, right. Yeah, not everything would need that.
You could do a tack switch instead of that strain gauge. All of a sudden, you're really just looking at $1 for the magnetic encoder and $5 for the gimbal and another couple bucks for the driver. It's not actually so bad.
Right. The screen would probably be the first to go, because you could argue that if you have some kind of device with multiple controls, you're going to have some main screen anyway, right? So like you don't need necessarily the screen. I'd like to see different spin-offs of it. I would just like to see more of it.
It's just so awesome, though, that it makes you want to think of how you could use it.
Well, that's where I was going. Like, it's almost like you would redesign your whole interface just so you have an excuse to use this thing.
And I just figured out what it's good for me, actually, while we were talking about this. I've got a CNC router in the basement, and I desperately need a jog wheel for it. And so I actually need not just one of these, but I think I need 3 of these, because you have to go X, Y, and Z, right? So I might have to work something like that up. But then thinking about that made me think about some of the problems with rotary encoders. And that is, you like to have fine control, so you like to have the clicks all really close to each other. But then when you spin it fast, you maybe like to go far so that you can have it. And a lot of people do this with rotary encoders. They'll notice that if you're turning it fast, they'll make it skip 10 steps. And when you're turning it slowly, they'll bring it down to single steps. But here, you've got variable haptic feedback. So when you move it quickly, you could have it go over a lot of little bumps. So you could tell, you would have feedback that you're doing that acceleration mode.
Right.
And then when you turn it slowly, you could space them out from each other, the little bumps. And you would, again, have feedback that you're doing the fine pitch control at that point. Or you could do it with force feedback, because you can also do force feedback with this thing. It doesn't just have to be detents. You can resist the person doing the work. So you could have it resist you harder and harder as it moves up its little acceleration curve. When you're skipping steps, it's also pushing harder back against you. This could be really, really interesting.
I can tell you're very excited about this.
You've got to build one of these. I think I may have to build one of these. We'll see. I have to get some of these. Anyway, I was shocked to see that these gimbal motors are so cheap. I'm going to have to order some of those whether I make the style or not.
Yeah, right.
That's going to be my jog controller. Oh, dude, now I am excited. Have a good podcast, dude. I'm out of here.
Half off sale today. Well, it's a new week, so that means a new Cyberdeck has to show up on Hackaday. And like many of the previous ones, this one is built into a Pelican waterproof case. But before you skip ahead, there is a little bit of something special on this one. One of the problems with building into these Pelican cases is always, how do you mount things into them without popping holes in the side? I mean, the obvious thing is you just drill through the sides and put screws in it, but then you lose the advantage of being like a waterproof Pelican case, and you pay dearly for that advantage when you buy a Pelican case, so you'd rather not do that, right? And of course, you could seal it up and all that, but, it's messy, right? Sizunic noticed that there actually is like an official Pelican like accessory bracket that is made to mount inside the box. it wasn't like this concept came out of nowhere. I mean, there are all kinds of, rugged military things that are built into these boxes. So the Pelican actually makes these little brackets that let you do a panel in there without compromising the integrity of the case. Being hackers, of course, we don't want to buy the official little adapter kit. So they have figured out how to do a little 3D printed version, and it's nothing crazy. I mean, it's just literally a little bracket and some screws, like some little self-tappers that go in there. But for some reason, and I look back at the old ones, I don't think anyone has ever done it this way before. Everyone has either punched holes in the side or glued their panel in, or a lot of them are actually just friction fit. They just they print the front panel. Like I actually went back to, I guess you say, the origin of this, the Back Sevens recovery kit, which was kind of like the first one we saw. And it's just friction. Like, it was just sized so that you pushed it in and it snugged up and then didn't pop back out. I don't know. Maybe this is not a feature that all the Pelican cases have, but I mean, it's now that we have the technology, now we have this little Pelican bracket technology. Like, I hope we see a lot more people using it, and they don't have to be cyber decks, right? You can build any kind of thing you want into these cases. And I'll say something. This might be a controversial take, actually. Maybe get some people mad with this one. I have never been super thrilled with the idea of these like Pelican case cyber decks. Because I don't, something about them being in a little box like that doesn't really say deck to me. Like, I don't know. I've always imagined like the classic Gibson cyber deck was like, old school Commodore or something like that. Like, it's supposed to be like a deck, right? Like, it's like these little fold up box things. I'm not really sure when we started calling them cyber decks or who was like the arbiter of that, but well, whatever you want to call it, whether it's a cyber deck or just your rugged drone controller or whatever, this one crazy trick, right, is going to make it a lot easier to build things into them without compromising the whole reason for having a Pelican case, which is that watertight, airtight construction.
I don't think I've seen anyone in the modular synthesizer world do this, but if you could make like Eurorack sized Pelican case, 3D printed Pelican case inserts that you could then just screw synthesizer modules into, you could have a Pelican case traveling waterproof modular synthesizer setup. Why have I not seen that?
Now we have the knobs to use on it too.
We're going to need a catchy name for this thing, because
right?
That's going to blow up. That's going to blow up.
And I should say, I kind of, maybe I undersold it where I said the little Pelican brackets aren't the only thing that makes this cool. It is a really a nice looking build. Got the RGB LED keyboard, and one of the cool things, there's a little secondary display with like a phone pad that is, I guess it's like hooked up to an ESP32, and it looks like the plan is to make that control an SDR. I think is what the IO
because it has
says.
two like BNC and
the
coming out of it. And
so that's really cool, doing like a physical control interface for an RTL SDR, which offhand, I'm not sure. Have we seen somebody do that? Cyberdeck or otherwise? I'm not really sure. That's a pretty cool.
I don't know. That's a fantastic addition, right?
Right. Yeah. Even as like its own little sub spin-off thing. That's a cool, like a physical interface for what we think of as, just this little USB dongle.
All right, this next hack plays to one of my secret weaknesses. This is Cool Mechanism Day, 2-way to 1-way. This is a cool mechanism and video describing it on the Mechanistic YouTube channel. This is the sort of thing that is used in those self-winding watches of old, where it's got a weight that moves around as you move your arm, and it winds the watch up no matter whether the pendulum weight swings one way or the other way. How does it do that? And the answer is these kind of two ratcheting wheels that rotate in opposite directions, but then the ratchets are configured so that it's kind of like a rectifier for movement instead of for electricity. But the one ratchets one way and the other ratchets the other way, and the end result is the output wheel always turns the same direction, regardless of which way the input wheel is turned, because one of the ratchets slips when it goes one way, the other slips when it goes the other way, but both drive the output wheel. It's really sweet to see how these work. I've actually never really wondered about it super hard, but I wouldn't have known how it worked. I'm really happy to see how it goes.
Kind of funny. I actually was watching, YouTube will do this to you, right? You just end up on some weird rabbit hole. And I found myself in the middle of the day watching people repair watches. And it is crazy. All the tiny little microscopic gears in there. And how they all relate. So it's cool to see some of those mechanisms blown up to a more relatable size, and they're just beautiful. I mean, it's a fascinating looking thing. I mean, even if you're not into watches or mechanical stuff, just talk about having like a cool little desk toy to just look at this thing.
It's a neat mechanism, I think, to have in your back pocket. I guess if you look through all this old watch stuff, it's probably like that. If you need to wind up a spring based on wave motion, right?
Ooh,
you have a bobber that floats up and down. You want it to wind on the upstroke and the downstroke, right? This is the mechanism for you. Or
did you come up and down off the top of your head?
I did actually.
I'm very impressed. And, part of me, I guess the thoroughly modern part of me, looks at these kind of things and is almost kind of dismissive, like, this is some antique, antiquated concept. We don't need to worry about this anymore. But then I think about the mechanism for the James Webb, Space Telescope.
Right.
Like the incredible, like, little geared mechanism, which, for whatever reason, it reminds me a lot looking at that. Even though we have evolved, I guess, technologically in some ways, there are still absolutely applications for this kind of thing on Earth and beyond. Don't be too dismissive of clockwork mechanisms. And finally, this one was kind of the surprise breakout success of the week, maybe. One of the most viewed articles, certainly. This one's called Reversible Ventilation Hack Keeps the Landlord Happy. The idea here is that Nick wanted to do a little automation on his heating and air conditioning system, but, as any apartment dweller can attest, you rarely have the luxury of changing out stuff without somebody breathing down your neck. So his challenge was to adapt the existing controller to hook it up to a home automation system with the ESP. And he, in a way, kind of lucked out because it turns out when we pulled the front panel off, there was a ribbon cable, only had, a handful of conductors, and he was able to figure out, not only does it have the buttons in there individually broken out, but it also had 12-volt power. So he was able to kind of make this little shim board where the panel connector goes in one side, comes out the other, and using the GPIO pins of the ESP, he's able to virtually press the buttons and get all the power he needs to run it. With the electronics settled, he then had to figure out a way to make it look not like a bomb taped to his wall. So the next step was to 3D print this bracket that goes around the original controller and kind of just adds, it almost doubles its size, basically. He was very careful to make sure it was like symmetrical and everything. And then put his own little logos on there too. If I walked into this apartment and I saw this thing, part of me would wonder why it was so big. But, it doesn't look like a DIY product. It looks very professional. I'm sure his landlord is very happy about it. And it gives him, the ability to turn the fan on, turn it off. It does seem like the system itself doesn't do a whole lot, because it just is like he can turn the fan on and off and that kind of stuff. But maybe it doesn't do an air conditioner. It could just be some kind of a fan controller or not.
Like you say, it's a beautiful case for it, and you should go through the gallery on Hackaday.io with this. It looks like it's a professional product, and then he pulls the little face off, and I'll be damned. It's like one of those little WeMOS ESP units and a boost buck converter, and a breadboard, and that's it, right? Like, it's underneath the nice facade, it's all hacks, but it's pretty sweet. This should be your weekly reminder that if you put a nice case around your ugly hacks, it becomes a nice thing.
Yeah, right.
And that I really like about this. The other thing that's really cool is that if you go through the comments, a bunch of people have said, hey, what kind of controller's in that thing? And it looks like they're going to help him reverse the controller for the device so that it's not just going to be button pressing, but maybe also some kind of more sophisticated reversing on that. I don't know if
that's cool. I didn't see that, yeah.
I don't know if it's necessary, but I love it when geeks see each other's projects and are like, hey, you could do this. My first quick hack this week is in 2045 Alpha Centauri. This is a report from Breakthrough Starshot, which is a project to get a solar sail-powered probe to Alpha Centauri within 20 years. And that means that thing is gonna have to be hauling. I guess I'd never thought about the problems of a solar sail. This one's intended to be powered by a super powerful laser coming off of the Earth. And that, of course, means that this thing can't melt. It also has to be kind of optimally shaped to absorb the maximum amount of photons pushing it along and stuff. This is a really neat report because it does some of the engineering towards something that used to be science fiction. Next up, Simple Arduino Build lets you keep an eye on Pi. Cristiano Montero built this project. It's a 4-digit LED display, and the Arduino underneath it calculates Pi digit by digit. It actually hauls along a lot faster than I thought, and that's due to a great low-memory Pi computing algorithm that is implemented on this. Go check that out in the GitHub if you need to start crunching your way through the digits. And last up, rotary phone MIDI controller still makes calls. This is yet another crazy synthesizer project from Kevin. This time he's hooked up an Arduino to a rotary phone, one of these old dial phones, and has it send out different MIDI notes and program change commands and even trigger entire sequences and stuff, depending on what numbers he's dialed. The demo video has him just playing a chord slowly by dialing each note in, and the notes kind of all accumulate up, and then he hangs up the phone and the synthesizers go silent. It's a really cute idea, and I just love insane MIDI controller builds, and this is pretty much the craziest.
All right, my first quick hack is from Lasers Over Los Angeles. It's how to make laser cut decals on the cheap. The idea here is you basically get your regular blue painter's tape, put it down the bed of the laser, cut the design out of it, and then use packing tape to peel it off the bed and put it on whatever it is you want to put a laser cut decal on. Granted, blue painter's tape is not the most robust of materials, and it probably won't last too long, but the pictures that they put up here are pretty impressive, and if you're looking just to spruce up something pretty quickly on the cheap, it's hard to argue with a roll of blue painter's tape and a diode laser. Next up is Mini PC Surgery makes it 50% cooler. This is from G3R, and this is one of those little tiny, little media PC. They're like the size of a book and largely airtight, which is not great for high performance computing. The problem here was they wanted to run some emulators, and it was overheating, so they basically just cut a hole in the top and put a comically large heatsink and fan on it. And it's all like the title suggests. They dropped the processor temperature by half. On a more personal note, reading this one, I discovered how easy it is apparently to emulate the Switch and play the new Breath of the Wild Zelda. So I have been doing that on my free time recently. And my last one is cheap Ghostbusters toy turned convincing prop. Now this one is kind of interesting. This is a video posted to the official Ghostbusters YouTube channel, where one of the prop masters from the new film Ghostbusters Afterlife shows how you could take a cheap Hasbro Ghostbusters toy and make it look more realistic, put new lights in, do a patina on the paint job and everything. The end result is really cool, and to start with a $15 toy and have something that could be potentially screen accurate is really cool. Part of me knows this is an ad
Yep.
for either the toy or the movie, but this is the kind of advertising I can get behind, and this is what they want to spend their advertising dollars on, showing how to make props. I'm all for it.
All right, that brings us to our Can't Miss articles. These are long-form articles written by our own Hackaday writers. This week, I'm picking Lewin Day's The Tasmanian Tigers Comeback Tour Powered by Science. And I don't know if everybody out there knows what a Tasmanian tiger is. I didn't until my son got a book about animals that nobody knows. And the Tasmanian tiger is one of those for sure. It's also known as the thylacine, and it went extinct in probably the 1930s. It's from Tasmania. It's not a dog, but it kind of looks like one. It's a marsupial, actually, and it's more related to the Tasmanian devil than to like a long dog or a stripy something that it looks like. They're really some of the coolest animals, being a carnivorous marsupial, and they apparently could run for infinitely long periods of time, but slowly. And that was how they hunted things, is they would just like chase it until it got tired, and then they would eat it. They're really awesome, but they're extinct. So some rich, presumably Australian, gave $5 million to the University of Melbourne to see if they could bring the Tasmanian tiger back from extinction. That sounds crazy given that it went extinct about 90 years ago, but it's not impossible. They have some specimens and they have managed to sequence the animal's full genome. The only problem remaining is then how you do the stem cells and the gene editing to then make a new embryo for an extinct animal. That would be amazingly insane. But people have worked on trying to like bring back woolly mammoths before. I think it would be the awesomest thing. The fact that it's a marsupial actually helps because marsupials, they spend most of their time actually in the pouch and not so much in the womb. So that kind of simplifies that side of things. You don't have to have it fully developed in an artificial womb. I don't even have any idea how the biology there goes. But then they can move it off into a Tasmanian devil as a surrogate mom. This is an insane project, but the more different species of animals that ecologists find, the more of them they realize are also going extinct. And so this kind of idea of being able to sequence a genome and then hopefully later in the future reintroduce this genetic diversity back into animals and then back into nature might actually become useful in the future. And so whether you care about Tasmanian tigers in particular, as my son totally does, or not, this may be good for kind of all sorts of species unextinctioning, which is totally a word.
Well, yeah, Lewin uses de-extinction several times, and if he says it's a word, then I'll believe it.
He probably got that from the literature. It probably is a word.
De-extinction, that sounds, I guess, better than, than
I will use that next time.
Yeah, the usual Jurassic Park. And speaking of which, the artwork on this one, as always, I think so, when we pick these things, sometimes it's as much for the Joe Kim art as it is the articles. Now, like you said, this is something that they've been talking about for like woolly mammoths for forever. I feel like this is, it's always been. But the big problem there is you don't have like a full genome for those. And I had read things like, oh well, you can mix a mammoth with an elephant or something and come up with some hybrid thing. But if you're gonna go through all the trouble and not really get a mammoth, like what's what's the point, right? The idea here is they have the full genome, and I guess a big part of that is because it only went extinct 100-ish years ago. It isn't something we have to pull out a fossil. So that is the advantage there. But then he also kind of Lewin says towards the end that it's a good thing and it's a bad thing because it also means that we only have like this one sample. There's not enough to have like a genetic diversity. If you say, all right, let's say you get one of them, well, what's that one going to mate with? You can't mate with a clone of itself. So that's going to be a problem. I mean, unless your goal is just to make a bunch of clones and study them, and then that's it. If that's what you want to put your money towards, whoever put the $5 million down, I guess you could just do a couple clones and study them, and then let them return to extinction. But if you want to actually have like a community of these things going, you're going to need more than that. You're going to need different genomes and that kind of stuff. And then he even says there's few, if any, living relatives of this thing that it could actually interbreed with. So it would maybe be a kind of a lightning in a bottle kind of thing. But even that would be an incredible achievement if they could even get one of these to birth and actually study it.
You're right. There's no way they'll be able to like repopulate Tasmania with these.
Right? Yeah.
I hadn't thought about that. That's a good.
Yeah, it would only. I think would only just be like as an academic experiment. Like, can we bring this thing back? Can we study it? Can we taxidermy a couple of them or whatever for future generations? And then let it just not make any more, because it really is going to be like an artificial thing. There's no way to just say, okay, off you go into the wild and start again.
But it does bring up the possibility anyway of doing that with other animals that aren't yet extinct. So if you could connect, if you could maybe collect enough genetic diversity that you could, get a good base for some of them. I don't know. This all sounds so kind of apocalyptic, futuristic that I don't like it. The idea of like storing all of the genetic material of animals to later repopulate the earth with them. But it'd be much easier to just not have them go extinct in the first place, right? You'd think. We haven't had cheap enough gene sequencing that you could do this until very recently. So in that sense, this is kind of a new possibility, and gene editing's come a long way. And the one side of me is saying it'd be cool to have Tasmanian tigers. The other side of me is like, oh, boo, we won't have Tasmanian tigers.
Yeah, not for long, right?
Thanks a lot, man. But then yet another side of me, how many sides, is saying this is a really cool bit of science. And it's good to see this carried through and see if it is at all possible. And, maybe it'll be useful later in the future. Maybe you can introduce genetic diversity into species that are on the edge of extinction, but not quite. I mean, we'll see. Anyway, good luck, Tasmanian tiger clone.
I was going to say, this is like kind of the genetic equivalent of landing on the moon, right? Like, we don't know what the spin-offs will be until it's done. So, you take on this incredible challenge, but that's not the end of the story. That's just only the beginning, My pick this week is Tech in Plain Sight, Tough as Nails by Al Williams. And I picked this one because this is, I guess you could say, the least likely Hackaday article I feel like I've seen in a long time. and granted, over the years, we've kind of expanded greatly, I think, what it means to be like a Hackaday article, right? But even still, I never thought I would read a long-form article about the origins and types of nails on Hackaday.com. But I did, and I loved it, and I think that speaks to Al's ability to, make this stuff relatable. You're talking about an article that starts, in Roman times, from an era where, each nail had to be made by hand, and it, wasn't super difficult, but talk about time consuming to make each and every nail. There was a time where nails were so valuable that like a family, if they were going to move, like they would burn their house down to get all the nails out. They'd burn the house down. Wait till it cools. Right, sift through, pull all the nails, pack them up, and take them with them, because wherever you're going, there'll be trees to make more wood, but they're not going to be necessarily nails, Or you couldn't afford, even if there was a blacksmith there, you couldn't afford to buy new. These were like heirloom nails.
Right.
It's crazy to think that we're talking about the same thing, that you could go to the big box retailer right now and pay for a couple bucks. But he explains how that happened and how it went from this forged by hand individually to like the modern wire nail, which is made in like thousands a minute, by one machine. Yeah. So imagine you got 100 machines, how many of these nails you have. But even that was a relatively recent development in the grand scheme of things. There was Tasmanian tigers, I think, still running around before they were really before we'd all switched over to wire nails. So, we're not talking ancient history here. I think it says 1913 is when the wire nails finally kind of took over. Not super long ago. He starts with the history of it and how we got to where we are now. And then you think the article's over? No, there's more nail goodness to come, because now he breaks it down into all the different types of nails. Did you know there was all kinds of nails? I mean, you probably knew there was one or two or three, but there's way more nails than you think there's nails. There's twisty nails. There's nails for stone. There's nails that are good for the weather. There's nails for your shoes. There's all kinds of nails, and it's just this kind of a running monologue of all the different kind of nails. And I'm sure there's more nails, obviously, than even Al
I bet
could
we've
fit in
missed
here.
some.
Yeah, you never get all the nails, right? And the one nail, it's funny, we're kind of behind the scenes where Al was talking about this article with us. The origin was the duplex nail. And he's like, does anybody know what a duplex nail? And some people claim they know, but I had my doubts.
I didn't.
No.
It looks like a little sword, not a nail.
Yeah, right.
Why would?
Yeah,
what's
why
up
would
with
you call it
that?
a nail? But it's just one of many types of weirdo nails. And, if you're curious, a duplex nail it's a nail that has a head, almost looks like a thumbtack to me, where you can easily pull it back out instead of the head going like flush with the wood. You're always going to have this little piece to get leverage on. It's an article on nails, right? I think that's the summation. It's an article on nails, and it's much more fascinating than you probably imagine. But at the very end, he says, or you could get screws, right? Because it's the future. We use screws. But he kind of retells this story. He said when Al says when he's a kid, people didn't like screws because it was faster to hammer them in, and now that we have high speed electric screwdrivers, that it's kind of changed the balance a little bit. It's called tech in plain sight, right? Like, so these are things that are just we take for granted, and what could be taken for granted more than like the lowly nail? Like, it's holding together whatever house you're sitting in right now. It's so key to civilization, but it's also a nail. It's really cool to see the history of them and see just the kind of variations and the types and the coatings, stuff that even if you have never and will never hammer a nail home in your life, I'm willing to bet you'll find it interesting to read through this one.
All right, that wraps it up for this week's Hackaday podcast. If you enjoyed it or have anything to say to us, let us know. editor@hackaday.com. You can always check out the show notes where all the links live, hackaday.com/podcast. And if you see anything cool or do anything cool, tips@hackaday.com. And until next week,
keep on hacking.
Oh, we've got weird... Damn it.
That's too much. You go to too much right off the bat.
Both kind of the voltage. Cool. Forgotted. Exactly.
How do you think?
Okay, here we go. One more time. Take it from the top. I don't like any of that.